So today we're gonna be doing a mathematics paper 1, that is for the year 2024 for the Northwest provincial government. Okay, so let's get into it. Okay, so we got the following question, that is factorized the following expressions completely. Okay, so they say leave your answer in the simplest form. So we're gonna start with 1.1.1. Okay, let's do 1.1.1 here. Okay, so it's 1.1.1. Okay, let me just increase here. Okay, so that is 1.1.1. Okay, so let's do it. It's like x squared minus 16x plus 15. All right, so that is our question. So first we multiply both there's a 1 here, so it's 1 times 15. So we look for numbers that we can multiply and get 15, but if you add them we can get a sum of what? Of minus 16. So which are those numbers? That is what 15 and what? And 1. All right, so we're gonna do like 15 and 1, so it's gonna be x squared minus 15x minus x plus 15, right? So we're gonna factor out the first two terms. It's gonna be x, factor out x here, x minus 1, x minus 15 actually, 8 minus 15, not 8 minus 1, 8 minus 15. Okay, so that is x minus 15. Then here we factor out minus 1, that is x minus 15. All right, so our bracket's gonna be like this, x minus 15. All right, so that one is 1 mark. We're gonna go to 1.1.2, 1.1.2. Okay, so this 1.1.1, 1.1.2. Okay, so what do we do with the second question? All right, so the question is, it's given this bracket plus 2b, right, minus 3, that is a plus b. Okay, so we continue factoring like this one. We can factor out like 2 here. So if we factor out 2, it's going to be 2a. Factor out 2 here is going to be 3a plus b, right? So here it's already factored out in its simplest form. Okay, so 3, that is 3a. Okay, we didn't take it right here. Okay, so let's just wrap it, because I see we left a 3a here. Okay, so we're gonna come here. Okay, 3a plus b. Okay, so now it's gonna be what? 3a plus b. So this bracket and this bracket are the same, so we can put this one in a bracket. So that's 2a minus 3. Then this bracket again, 3a plus b. Okay, so that goes for the first two. Let's go on to the next one, which is 1.2. Okay, to the next one, which is 1.2. 1.2. So it says simplify the following expressions completely. So we got here 27 to the power of 2/3. Okay. Okay. to the power of a third. Let's just to the power of a third here, bracket 2. So we didn't break any math rules here. We just separated like the top here. We just want to deal with 27 to the power of a third, so that we can actually write it like this. It's like 27 to the power of a third is cube root of what? 27, right? So it's more like cube root of 27 squared. Okay, so cube root of 27 is what? If we multiply 3 by 3 by 3, we get 27. So our cube root is what? Is 3. Then it remains as 3 squared. Then our answer is equal to what? It's equal to 9. All right. So let's go on to the next one, which is this expression here. Okay. So we go on to 1.2.1. 1.2.1. Okay. So we got that expression. That is x plus 3 over x minus 3 times x cubed minus 27 all over x squared minus 9 divided by x squared plus 3x plus 9. Okay, sorry for that. Let me just come over here. Okay, let me just do this. So that we can get more space here. Okay, so that we get more space here. Let me just try to rewrite this. Okay, let me just rewrite the expression. Okay, so we got more space here. We're gonna write 1.2.2. So we x plus 3 over x minus 3 times x cubed minus 27 all over x squared minus 9 divided by x squared plus 3x plus 9 all over x minus 3. Okay, so let's start by factorizing our components here, whatever we can factorize, right? All right, so remember, like this one on top, these two here are already simple, but this one you can factorize it further, and this one also, it's different of 2 squares. So let's say, and this one also we can factorize, that is what, 3 and 3, and do we need to factorize it? Okay, let's just see when you factorize this one what we can get, so that we see if you can factorize this one further. Okay, so we're gonna try to factorize this one in this expression here. All right, so we're gonna write it like what? So like x plus 3 over x minus 3. Okay, so times, so this one the form we can do when there's a cube here. Okay, and so this one is a cube. This is what we can do. We just take this expression, the cube root of this expression, which is what? X minus cube root of 27 is 3, right? Close it. We take this one, we square it, right? Then we change the sign here to plus. So it's always, it interchange the sign. So now it's plus 3 times x right? That is 3x. Then this one squared, the minus 3 squared is going to become a what? A plus 9. A plus 9. All right. So all over what? So if we do difference of two squares here, we're going to get what? X minus 3 and what? X plus 3. Okay. So here there's a division sign. Okay, let's leave this for the meantime. Let's see. Because these are the pointers. You see here we got this expression, but here we also have it, so we don't need to factorize it further, because these ones, let's see if they can try to cancel out. Okay, so over what? X minus 3, right? Okay, so let's just take this x plus 3 over x minus 3, that is a times x minus 3, right? This one, then x squared as 3x plus 9. That is all over what? All over this x minus 3, then x plus 3. Then here, since there's a division, if we want to put a times, remember this one flips over, the denominator becomes the numerator. Okay, so it's kind of like this, x minus 3 all over x squared plus 3x plus 9. All right, so now we see we have some common terms here which can cancel out, like this one will cancel out with this one, right? And also this one can cancel out with this one, and also this one can cancel out with this one, and also this one will cancel out with this one. So what do we have remaining? We have an answer which is what? This is 1 over 1 divided by 1 over 1 divided by 1 over times 1 over 1 here. So everything becomes what? You get a term which is 1. Okay, let me just write it nicely here. Okay, so we get a term which is 1. Okay, so that is our answer, and you get your 4 marks. Okay, so let's step on to the next one. So okay, we have this expression here, which is 3 to the x plus 1 minus 3 to the x plus 2. That is over 3 to the x plus 2 plus 3 to the x. Okay, so here we basically see these expressions where 3 is the base. Okay, so let's try to separate the terms on the powers here. So we're gonna do like this. Because this one is in simplification, we're gonna do like 3 to the x, right? So by the laws of indices, for this one to aid, we have to multiply because the base is 3, but the powers are different, so it's going to be like this: 3 times what? 3 to the 1, right? So that when you combine these powers, remember, when you're multiplying and they have the same base, the powers, they add up. Okay, so we go on to this one as well. We do the same. That is going to be 3x times what? 3 squared, right? All right, all over. That is what? 3 to the x times 3 squared minus 3 to the x. Okay, so what you can see here from the top and the bottom, the common factor is what? 3 to the x. So what can we do about it? We can factor it out. Okay, so let's factor it out on top. It's going to be what? 3 to the x, right? That is what? 3 minus, that is 3 squared, right? All over what? Also, this one is what? 3 to the x. All right. 3 squared minus 1. All right. Okay. So this will give us what? So the 3x cancels out. Okay. Then we go to what? 3 minus 3 minus 3 squared, which is 9, all over 3 squared, which is 9, minus 1. So we got our answer is what? Minus what? 6, all over 8. All right. So there you go. Then you can get your 4 marks. Okay. So let's go on to the next one. Okay. So 2.1 is requiring you to solve for x, where we have this expression that is 2 dot 3 to the 2x, right, is equal to 18. So since we are solving for x, let's just leave the terms with x here. We isolate it. So yeah, since it's a dot product, we can actually divide by 2 this side, divide by 2 this side. Okay. So these 2 cancels. We remember with the remainder is going to be what? 3 to the 2x, then 18 divided by 2, we get a 9. Okay. So since we have an expression with base 3, we can try to put this one also as a factor, as a number with a base 3. Okay, so it's 3 to the 2x, right? And here, if you can put 3 here, it's going to be what? 3 squared. That's the number you can have with the base 3 to get a 9. Okay, so it's 3 what? Squared. Okay, since both of them have the same what? Base, so which means 2x is equal to what? It's equal to 2. Okay, 2x is equal to 2. Then here we divide by 2. Here we divide by 2. So now our x becomes what? 1. Okay, then get a 4 marks. All right, so now let's jump to the next question, which is 2.1.2, the 3, right? So we remove this denominator, we multiply both sides by 3. We're going to get what? A 2x minus 1 is greater than or equal to 3 bracket 2x plus 1, right? So it's a 2x minus 1 equal to, this one becomes 6x plus 3, right? Okay. So now we put the terms with x on one side, that's going to be 6x minus 2x minus 1. This one comes this side, it's called actually minus 4 here. Right? All right. So now it becomes what? 4x here. It's equal to minus 4. We divide it by 4. We divide it by 4. Okay, now we get a what? I get minus 1 is less than or equals to x. Okay. So that is our answer. We can actually represent it like this. It's fine. Minus 1. All right. So that is our answer. We can go on to the next one. 3. Okay, so we are having this expression here, which is 2x squared minus x minus 10 is equal to 0. Okay. So we got this quadratic expression. What do we do to find x? Okay. So what you do first, we just factorize this. All right. Then we equate it to 0. Okay, so here we got these terms, which is 2 times 10, which can give us 20. So what are the numbers we can multiply to get 20? But if we add them, the sum is going to give us a what? A minus 1. All right. So what are the numbers? Which is 5 and 4. Okay, 2x squared, so minus 5x minus 4. Yeah, now it becomes a plus 4x, so that we get a minus x here, minus 10, right? It's equal to 0, it's fine. All right, okay. So now we come here, we factor out x here. We're gonna get what? 2x squared, 2x minus 5 Then here, what is, okay, we can factor out 2 here. Okay, plus 2, 2x, right, minus 5 is equal to 0. Okay, now we get this brackets, which is x plus 2, 2x minus 5, equated to 0. Okay, so now we have this expression x plus 2 is equal to 0, or 2x minus 5 is equal to 0. Okay, now here we just come, this one crosses over, then x is equal to minus 2, or, okay, this one crosses over, it's going to x is equal to 5, so divided by 2, divided by 2, so x is equal to what? 5 over 2. Okay, so our answers are x is equal to 2, or x is equal to what? 5 over 2. All right, so let's get on to the next one. 2.2 is saying how much must be added to x plus 5, x minus 5, so that it will be equal to x plus 1 is equal to x plus 1 bracket x minus 25. Okay, so they're saying what must be added to x plus 5, x minus 5, right? Okay, so let's say what we're going to add, we equate it to what? To a. Okay, so they're saying what must we add, what is a, to get to x plus 1, x minus 25. So let's rewrite this one. Okay, x minus 25. Okay, so they're saying what must we add an x plus 5 bracket x minus 5 so that we get to this term, which is x plus 1 bracket x minus 25. Okay, so let's say we need to add a to get to this. Okay, so a is our variable here. So what are we gonna do? Okay, so let's try to expand these brackets so that we see which term is missing there. Okay, x plus 5, we get x squared minus 5x, right, plus 5x. 5 times minus 5 minus 25, right? Okay, plus a, we equate it must get to this, which is x squared, right? Minus 25x, right? Plus x, right? Minus 25. Okay, so here we see that minus 5x plus 5x, if we add them together, this one's a negative, this one's a positive, so it's going to become a 0 here. So it's going to become x squared minus 25 plus a is equal to x squared minus 25x plus x minus 25. All right. So here you can see minus 25x plus x, we're going to get what? Minus 24. Minus 24, x squared minus 24, x minus 25, right? So we can see all the terms are common here, x squared and minus 25, x squared and minus 25. So the missing term is this one, which we can equate to a. So our a is equal to what? We can actually subtract this as well. We just put it to one side. We make a subject with formula. We put this one to the one side. So these ones will cancel out. This one becomes negative. X squared minus this one. Then this one also becomes positive if it crosses over this equal sign. So that it becomes what? Okay, let's just cross it over so that you guys see it perfectly. 24x minus 25, right? Now we're gonna subtract minus because when this one crosses over, it's going to become negative. Then this one is going to become a positive, which is plus 25, right? So x squared minus x squared is going to become 0, minus 25 plus 25 is going to become what? 0. So our a is equal to what? A is equal to negative 24x. All right, so that is our answer. Let's go on to the next one. 3. Okay, so 2.3 is requiring us to solve for x and y simultaneously. Okay, so we're gonna write here, it's what? Y is equal to what? Okay, this 2.3, right? Y, let me just rewrite it here. Very nice. Okay, so it's 2.3. Y is equal to what? It's actually y minus 3x is equal to minus 2, and also we got 7x minus 2y is equal to 8. Okay, so what we can actually do, we can try to okay, let's call it equation 1. Okay, this one equation 2, right? Okay, so what we can do, we're going to try to multiply equation 1, right, by 2. Okay, going to multiply by 2, then it becomes what? Then it becomes 2y minus, we multiply this one by 2, it's going to become what? 6x is equal to minus what? 4. All right, so let's try to multiply also equation 2 with what? With times 3. So what we're trying to do, we're trying to eliminate we're trying to eliminate already now I see we can actually eliminate without multiplying here. We can eliminate because there's already a 2y here, so we got a 2y on here and we got a 2y here, so we can eliminate it from here. Okay, so there's no need to multiply here. All right, so there's no need to multiply here. So what we can do, what can we do so that this one becomes equation, let's say equation 3, right? All right, so what we can do, what can we do so that there's 2y in this one, the result summation of it, algebraic sum becomes 0. So what we're gonna do, this one is a positive, this one is a negative, so we actually, if we add them together, 2y plus minus 2y, we're gonna have a 0. So we're gonna add equation 1, 2, no, it's actually equation 3 actually. Okay, this new one, 2 equation 2, right? Okay, so now when we add, we're gonna have what? 7x 7x minus 6y, we're just taking the common terms here, right? Plus here we got a 2y, right? A 2y a 2y plus minus 2y, right? Then we get to this side as well, minus 4 plus 8, right? So that here we can eliminate this one. We're gonna have a 7x minus 6x, which is equal to x, right? Plus 0 is equal to minus 4 plus 8. We can get plus 4 here. Okay, so x is equal to what? is equal to 4. All right. So now when you get x, you can substitute this x into any, let's use substituting 1. Okay, you can use any of these three, any of these equation that we have, 1, 2, or 3, but let's just use 1. Okay, substitute x is equal to 4 into equation 1. Okay, now we're gonna get what? Our x is 4, y minus 3, x is equal to 4, right? Is equal to minus 2, right? Okay, y minus 12 is equal to minus 2. Okay, now we can get y is equal to minus 12. If it gets this side, it's going to become positive. So it's going to become minus 2 plus 10. So our y now will become what? Okay, let me just. Our y now will become what? Minus 2 plus 10. So our y becomes what? Becomes 8. Okay. Actually, I just messed this up. Yeah, I'm being too fast. Sorry guys for that. Okay, so this is minus 2 or 12 here. Now I was writing the resultant here already and subtract it again. Okay, and this one is 12, right? So our y becomes what? Minus 2 plus 12. Our y becomes 10. Okay, so these are the things you have to look out for in an exam. So most probably, because you know it, you'll be rushing. Because most of the time, things that you know you may be rushing, and these are the mistakes that you can come up with. So just look out for these ones. All right, so let's go on to the next one. Okay. All right, guys. So in question 3, we got some diagrams. That is diagram 1, diagram 2, and diagram 3. Okay. So in each diagram below, there are shaded squares and white squares. Okay. So they're saying 3.11. Write down the formula or general term for the number of shaded squares. Okay. So now what sequence do we see here? Okay, in diagram 1, we got 3 squares, which are shaded. In diagram 2, we got 6 squares. In diagram 3, we got what? 9 squares. So the sequence is what? We're gonna write the sequence as what? 3.11, right? 3.11. So this is the sequence. Okay, 3 here. We're gonna go to 6, then we go on to 9. Okay, right? So that is our sequence. So what is the general formula? Okay, we can try to write it as what? The term, okay, nth term, right? Nth term is equal to dn plus c. Okay, so where d is the difference between the terms here. All right, so we see there's a difference of what? 3, gonna be 3n plus c. But how do we find the c? We're gonna equate it, let's say the first term here. Okay, so when n is equal to 1, first term is equal to 3. So that one must equate to what? 3n plus c must equal to what? To 3. Okay, so now n is 1, 3, 1 plus c is equal to 3. Okay, so that gives us 3 plus c is equal to 3. So our c is equal to what? We take this one this side, it's going to be 3 minus 3. Our c is going to be equal to 0. So our nth term is going to be what? Formula for nth term is going to be what? Just 3n. All right. All right, so let's go on to the next one. 3.1. So we're going to go to 3.2. So what we can actually see from this one is a linear sequence where there's a constant number that you have to add when you're going to the next term. Okay, So now it's going to become what? 3.2, 3.1.2. Okay, so they're saying determine the number of shaded squares of diagram 300. Okay, so we have our formula for nth term is equal to 3n. So now we got this number here. So we're going to equate 3n is equal to what? 300. So we divide by 3, divided by 3. Our n is equal to what? No, actually, this is not what they're requiring. So they're saying determine the number of shaded squares of diagram 300. So diagram 300 is the 300th term. Okay, so it's the 300th term, right? So our n is 300. Okay, so we got this one. We got this nth term is equal to 3n, right? Right? But now our n is equal to what? Diagram 300. Yeah, our n is equal to 300. Okay. What's the number of the diagram? That's the term. Actually, because diagram 1 is term 1, diagram 2 is term 2, diagram 3 is term 3. So diagram 300 is going to be what? Term 300. Okay. So we're going to get what? 300 times 3, which is going to be 900 shaded squares. Okay. Okay, so there you go. So we're going to go to 3.1 or 3. Okay, let's start 3.1.3. Okay, what are they requiring? Which diagram will consist of 1500 shaded squares? So now we got our 3n. Now we're looking for the nth, which term, which is n, will result in what? 1500 shaded squares. Okay, so now we're just going to divide by here by 3. So divided by 3 this side. So n is going to be what? 3 into 15, that's 5. Okay, so it's going to be what? 5.00, which is 500. Okay, so diagram what? It's going to be diagram 500 will give us 1500 shaded squares. Okay. Okay, now we're gonna jump to 3.2. Okay, 3.2. Okay, so let's okay. So now we got this question. If the pattern terms continue on the same way, what will be the 308 and 83 later? Okay, 383 later. Okay, so let's come here. Okay, let's come here. So we're gonna write that is the term here, which is what? Just gonna continue like that. 10. This is there. Okay, times. All right. So it's gonna continue like that. Okay, we're gonna do like that. It's gonna continue like that. Times. Continue. Okay, keeping the same pattern. Okay. So it's gonna keep the same pattern, right? So what we can see, we have this term here, which has got what? How many terms? Which is in repetition? 1, 2, 3, 4, 5, and repeat 1, 2, 3, 4, 5. Okay, so the term consists of what? Okay, the term consists of 5 letters, right? Okay, so it's gonna keep on repeating, but having 5 letters. All right. So whatever the number we're gonna get, when it goes, it's gonna be a multiple of what? A multiple of 5. Okay. So let's see here. Let's try to divide this number here so that we see a remainder. We're gonna see a remainder. Let's divide by 5, because the letters 5, 1, 2, 3, 4, 5. Okay, so we need multiples of 5. Every multiples of 5, the term is full. Okay, so now let's see which term will fulfill these or terms, which is terms, uh, without leaving a small remainder of the terms here. Okay, let's see. We're gonna do like what? So we get this number. It must be 383 over 5. What do we have? Okay, so if you say 383 over 5, you're gonna have 76.6. Okay, so the whole number is what? 76. So now let's look at what is 76 by 5. Okay, we wanna see when the terms will continue repeating but fulfilling all the terms here, all the letters here on terms. Okay, 76 times 5, you're gonna get what? That is what? That is 380, right? So after 380, you're gonna restart again with these terms. Okay, so we're gonna go 380, right? Then you're gonna go 381, start here, 381, 382, 383. So this will be the term. So they are asking what? Continue. What will be 383 later? Okay. So the 383 later will be what? Will be R. Okay. So we're going to write it like this. 380 later is equal to what? Letter R. All right. So let's continue again. Let's continue again. We're going to see what? Okay. We're going to go to 303.3. Okay. We're going to come here, right? 3.3, right? 0.1, actually. So they're saying consider the following pattern. We got so the pattern is like this. At 22, 29. All right, there you go. So in case you're gonna require the question paper, so that I send you the question paper. So at the moment I don't have enough subscribers to put in a link, but if you require one, you can just highlight it in the comment section. You just subscribe and then I send it to you. All right, so we're gonna keep it that way until actually when I reach 1000. Then you guys, I can just set it there in the comment section as a link. Okay, so we're gonna do like this: 8, 15, 22, 29. All right, so they're saying write down the next 2 terms of the pattern. All right, so okay, so they didn't mention here. They didn't mention if it's a linear or what. Okay, so we're gonna try to see what's the difference between 8 and 15. We're gonna be 7. From 15 to 22, that's 7. From 22 to 29, that's 7. So we see there's a constant what? Number. you have to add all the following time. So this one is a linear what? Linear function, linear sequence actually. So write down the next two terms. The next two terms we're gonna just add plus 7 plus 7. So the next term is gonna be what? 29 plus 7. 29 plus 7, which is 29 plus 7, that's got it 36. The next term is gonna be 36 plus 7. We're gonna get what? So for 43. Okay, that's it. Okay, so those are the terms. The next term, so we can write it as what? 8, 15, 22, that is 29, that is 36, that is 43. Okay, so what are they requiring next? Describe the pattern in your own words. Okay, so in our own words, how can you describe this? Okay, so in describing this, we can actually say the pattern started at 8. The sequence actually, the sequence um, started at 8, and then after each term, and we add um, 7 after each term. Okay. All right. So this one is a linear sequence. Actually, just have to highlight it. It's a linear sequence. We start at 8 and we add 7 after each term. All right. So let's go on to question 4. 4.1 is stating that. Let me just write here. 4.1. Okay. So the question is stating that Mark has booked himself a hotel room for 3 nights during his visit to New York. The exchange rate during his visit was a dollar as to what? 9.10 cents, right? The cost per night of the hotel was 450, that is dollars. How much did the 3 nights cost him in rents? Okay, so the cost per night is what? It's $450. $450 per night, right? But now it spends how many days? In 3 nights. So in 3 nights, we're gonna multiply this one by 3. 3 nights, right? It's gonna be 450. That is in dollars. 450 by 3. We're gonna get what? So we get 450 by 3. We're gonna get 1,350. 1,350. That is dollars, right? Um, all right. So in rands now we have to convert because we get a dollar. $1 is costing what? 9.10 cents, right? So now what is $1,350? Okay. Now we have to say what? 1,350 over 1 times 9.10 cents, right? So now this gives us what? That will give us a total of what? 12,285 rands. Okay, so that is the total you paid for the 3 nights in rents. All right, so now we're gonna go to 4.2. All right, so what is 4.2 sign? Okay, so this is 4.2. A television set costs 20,000. That is rands. Belinda buys it on higher purchase. Okay, so she traded in an old television for 3,000 rands and also paid a deposit of 2,000. All right, she made monthly installments of what? 900 rand for a period of 2 years. Okay, so as you know, Higher purchase, it's always calculated as simple interest. Okay, just to highlight that. Okay. So what do you do? They're saying on 4.2.1, calculate the total interest paid. Okay, total interest paid. That's what you are calculating. Total interest paid. Okay, right. So we have what? She made monthly installments of 900 rand for 2 years, right? So the monthly installments. Okay, let's start with this one. We just write what we have here. So the deposit is equal to what? 2,000 rand, right? And then we got monthly installments. Okay, let's just write installments here. 900 rands, all right? So after 2 years of the monthly installments, okay, after 2 years, 24 months, right? The total of the installments will be what? 24, because we got 24 months in 2 years, 24 times 900 rands. What are we going to have here? So we're going to have 21,600 in total in the installments. Okay, all right? Total installments. Okay. Okay, so we get 21,600. All right. So that is the installments. All right. Okay. So now we have um okay, the total interest paid. So the television costed 20,000, right? The television costed 20,000. That is in cash. Okay, but now we did a higher purchase, which required us to pay a deposit of what? 2,000, and the installments, which in total cost 21,600. So now, because of higher purchase, these are the amounts we paid. We paid the deposit, and the total installment plus the total installment amount, right? So if we add these ones together, we're gonna have what? We paid what? A deposit of 2,000 plus the total installment amount, which is gonna be what? 21,600, right? So the whole amount we paid due to higher purchase is gonna be what? 23,000. That is right. 23,600. All right. So let me just go down. So it's gonna be 26,600, right? So now we're gonna try to calculate the total interest that is paid. Okay. So what is the total interest that is paid? We're gonna find it using this amount we paid actually, subtracting the amount we were supposed to pay if we're going to pay it in cash. That is 20,000. So the total is the difference in those two numbers, which is the higher purchase amount. Total interest paid is gonna be what? Total interest paid, right? It's gonna be the higher purchase amount all right, amount minus the cash price, right? So we're gonna do it like this. It's gonna be 23,600, right? Subtracting, we got 20,000 rands here. So the total interest is gonna be what? Which is 3,600, right? Okay, so that is our total interest that is paid on top. if we're gonna do the higher purchase. Once we did the higher purchase, it's the cash payment. Okay, so now let's go on to the next, which is calculate the simple interest rate. Okay, how are we gonna do it? So in calculating the simple interest is called what? Where we have this formula for simple interest, which is accumulated amount, is called to what? P, right? Which is the principal amount, 1 plus I n, right? Where I is interest, that's a decimal, and n is the number of years. All right. Firstly, what you have to do is to calculate what is the principal amount, all right? So principal amount is always the cash price minus the deposit. Okay. Principal amount, P is called what? Cash price minus the initial deposit that we have to make, because interest is always charged on the remaining amount. So we have to take out what? The deposit, which is equal to cash price. It's what? 20,000, right? Then the deposit money we deposited, that is 2,000. And okay, so our principal amount is going to be what? 18,000. There you go. That is 18,000, right? So now we're going to try to calculate now. Since our total installments are accumulated to what? So the accumulated amount is what? A, we already calculated it in the previous workings that I just erased there. We got 21,600, which is the total installments in what? In 2 years. Okay, so that is the amount for A. So now we're going to try to equate now. 21,600 is equal to what is our principal? It is 18,000, right? 1 plus our N is 2 years, okay? Then 2I, like this. Okay, now we have to divide by 18,000, divide by 18,000, right? We're gonna get what? Let's see. So we're gonna get this term here. Let's just make 2x subject of formula here. So it's gonna be 21,600 all over uh, all over 18,000 minus, we're gonna take this one, it's gonna go this side, it's gonna become a minus 1. It's equal to 2I. All right, it's equal to 2I. So now if we punch this one in your calculator, you're gonna get what? 0.2. If you punch this one in your calculator, it's equal to what? 2I, right? So divide by 2, divide by 2. What's gonna be our I? Our I is equal to 0.1. So our interest as a decimal is gonna be 0.1, which is what? As a percentage, you're just gonna multiply it by what? 0.1 times 100%, because it's always given as a percentage. It's much simpler that way. Okay, 0.1. Now we get what? 10%. So that is our interest. 10% per what? Per annum. All right. So our answer is going to be 10% per annum. Right? Annum, which mean per year. All right. So now this one is done. But you must always remember when you're working with, even if they don't highlight, they just give it, calculate the interest rate. You must always remember when you're doing higher purchase, it's always simple interest. Okay, now let's go on to the next one. All right. So on this question, they're saying, let's write it question 5. Okay, so it's gonna be question 5.1. Okay, so we got these two graphs, which is f of x, right, is equal to minus x squared plus 4, and also we got g of x is equal to 2 to the x, that is plus 3. Okay, so they're saying we must sketch these two graphs on the same set of axes on the diagram sheet provided. Okay, so we're not gonna do it on the sheet they provided. We're gonna do it here on our own space. Okay, so let's try to look at the two graphs. What are the characteristics? Okay, so we see here we got a form which is y is equal to ix squared plus q. This is a parabola, right? Which one? This one which comes with a quadratic form. Okay, then we go to g of x. No, actually, it's actually f of x, but okay, it's fine. G of x is equal to 2 to the x plus 3. Okay, so this one, we actually see that there's a formula like this, ab to the x plus q, which is an exponential graph. All right, so normally these graphs looks like this. Okay, this one is actually a cup shaped. Okay, sorry for the lines going not really straight there. Okay, so a parabola, I'm sorry, yeah, let me just redraw it. Very nice. Let me just try to set this thing. Okay, so it's gonna be what? Gonna be like okay, normally these graphs are like this. All right, this one is normally cup shaped, and it comes in on 0 and it goes like this. Where the asymptote, if it's like this, y is equal to x squared. All right, we started from there. Y is equal to x squared. Normally it is a cup shape like this, and the bottom number here it's gonna be 0, where y is equal to x is equal to 0. We're gonna have the exponential as well. It looks like this. Okay, then it goes up, where the notable point is usually it's gonna be like this. Y is equal to b to the x, right? So notably this point here, it's gonna be 1, right? Okay, so these are notable points. This one, it's gonna be cup shaped, but it's gonna come here. The minimum value is gonna be 0, and also this exponential one, it's gonna be like this, going towards 0 here, but never touching 0. Okay, then it goes up like this, right? It goes up like this, so it's always positive if it's like this, right? Going upwards. And also here, it's always going to be positive, but it's gonna be like a cup shape like this. So the notable points, this one, the minimum here, it's gonna be 0, and this one here on the exponential one, this value is gonna be what? It's gonna cross the y-axis on the value 1. Okay, now let's see what are the transformations here. Okay, so this one has got a negative, which means all the positive values of x, right? This one is gonna result in positive because it's a square, right? So which means all these positive values gonna be turned negative, which means it's gonna reflect. Okay, so this is the transformation is gonna reflect. If you see a negative here, it's gonna reflect on the x-axis, right? That is the reflection that is gonna happen. So it's gonna come down, Okay, so let me just try to do the transformation here. Okay, so this one is like right, sorry. Okay, so this one is gonna be like this, but now this one's gonna be like, it's gonna be reflected down like this, right? Previously all these values were on the positive y. Now because of that negative x, yeah, it's gonna be a mirror reflection um, in the using the this x-axis. All right, so it's gonna start positive and go negative, right? um but now also, okay, it's gonna start like this. Sorry about my drawing. Then it's gonna reflect like this, that is minus, right? Now we're gonna do also, we're gonna see also there's a 4 here, right? Which means this graph is gonna be translated 4 units up because it's positive, right? So it's gonna result in all the values of y being added at 4. So it's gonna start from here but go like 1, 2, 3, 4 units up, right? So it's gonna go on top here. So this is the result. Let me just draw it maybe aside here. So it's gonna go 1, 2, 3, 4, right? Going upwards, uh, right? Going upwards now. Our shape is gonna look like this, right? Okay, so also a point to note is when is it gonna cross the x-axis? So when it crosses over the x-axis, it crosses when y is equal to 0. So what are we gonna do? We're gonna do equate this one to 0. Then we find the points it is crossing on the x-axis. So it's gonna be like what? It's gonna be like let me just rewrite it down. Minus x squared plus 4. So we're gonna have okay, so it's gonna be 0 is equal to minus x squared plus 4, right? Then you put x side, it's gonna be like this. So the square root of x squared to square root of 4. So now our x is equal to plus or minus 2. Remember the square root of 4 is plus or minus 2. So as you can see, this one, this side is negative, this one is positive, so the negative is going to come here, negative 2, then the positive 2 here. Okay, so now let's go on and do the one for the exponential. Let's see the transformations that happens there. Okay, okay, so let me just leave this one here. Let me just try to remove this side and do the one alongside for the exponential part for g of x. Okay, let's go for g of x. So g of x is 2x plus 3. So normally the graph is like this. Our graph is like this. Okay, for that number 2, okay, for the 2x. Okay, so y is equal to 2x, 2 to the power of x actually. It's like this, so it's gonna cross here when the value of x is equal to 0, 2 to the 0 is gonna be 1. Okay, right? So that is our g of x. But now we see there's a transformation here. So all the y values, we're gonna add a value of 3, so it's gonna be shifted 3 units upwards. So it's gonna be 1, okay, 2, 4, 5. So okay, we're gonna shift by 1, 2, 3 units upwards, so it's gonna come and cut here, so it's gonna look like this. So okay, all right, so that's the transformation here. Let's see here. Now we're gonna draw it on the same axis. Let's just try to draw it as much as we can on the same axis here, like this, right? Okay, this is the y, this is the x. Okay, y-x, right? Okay, so this one is cup shaped, but it's gonna cut at 4. Okay, 1, 2, 3, 4, 5, 6, 7, and -1, -2, -3, -4, -5. So 1, 2, 3, 4, 5, 6, so -1, -2, -3, -4, -5. Okay, going on. All right. So this one is going to be cup shaped, but it's going to cut here. So it's going to cut at 2, and that's 2 here, and it's going to come here at 4. Okay, so it's going to be like this. Sorry for the drawing, which is not so nice, but it's actually cup shaped. Okay, let me just try to draw it nice here. Okay, it's going to be like this. All right, and also our exponential, because now it's going to cut it at 4 here. All right, it's going to go like this, and the asymptote is never going to cut the 1 unit, which was at 0. Now it's 3 units upwards, so it's going to come like this. Okay, so that's the sketch. Now we can go down on the next one. All right, so that is our sketch. Oh, so let's just write it here. G of x is equal to this one. This one is g of x, right? And that one is f of x. This one is f of x. Just to highlight which one is which. Okay, so now we're gonna go to the next one. So we're gonna come on 5.2. Go to 5.2 now. 5.2. Okay, so now we're gonna write down the coordinates of the turning point of f. Okay, so as we previously see on our sketch, our turning point now became it was like this, né? So our turning point was like this. So it was on 1, 2, 3, 4, as you can recall. So it was like this. All right. So this one here is our turning point, the maximum value. All right. So our turning point of f of x, turning point is what? Is equal to turning point is equal to 4, right? Y is equal to 4 there. And also we can write the coordinates as suppose here it's 0 on x, so it's 0 and 4, right? So that is our turning point. Okay. Let's go on to the next one. Now they say the graph of h of x, right? X squared minus 4 is obtained by transforming the graph of f. Okay. The graph of f describes the transformation that maps the graph of f onto the graph of h. Okay, so what we have on g of x is written is like this. G of x is equal to 2 to the x, right? No, we actually have a transformation from f of x, not g of x, right? We're using f of x or g of x, so we're gonna have f of x, right, is equal to negative x squared plus 4 right? But we want to transform it to h of x, right? It must transform to h of x is equal to x squared minus 4. Okay, so what are we going to do to this graph to make it like this? All right, so now you see what they did here. It was a negative, right? Now it's a what? It's a positive, which means it's going to be a mirror reflection. It's going to be a mirror reflection because it was like this, and the maximum value was 4, right? So now this one is positive, which means all these values, we're going to have a mirror reflection because it changes the sign here. It's going to be a mirror reflection. So all the negative values going to become positive. So it's going to reflect like this. Because now this one is the mirror line. It's going to reflect. Now it's going to become cup shaped again, but facing upwards. All right. It's going to be like that, facing upwards. Right. When there's a change of sign, there's always reflection. Okay. So you must take note of that. Okay, now it reflects in this line here. Now they translated now also this value here, right? Now it's minus 4, right? So this one was plus 4, right? This one was plus 4. Now it's going to be gonna go minus 4 downwards. Okay, so this one is for the plus 4, which means 4 units we've already transformed going up. Now this one, we're going to transform this graph, which is x squared. Okay, so the x squared, it's going to be like this. It's already transformed, but now it's what? U shape. Let's just leave this one for the part here so that we see the transformation only on the x squared graph. Okay, so this is the x squared graph, x squared, right? So now this one, it's what? It's transforming 4 units down, which is negative. It's gonna go minus 1, minus 2, minus 3, minus 4. All right, so it's gonna be transformed. It's gonna come 1, 2, 3, 4 units. So it's gonna come now the final graph will be like this, right? So what is the transformation here? What is the transformation? So this is our graph here, which is our original. Then it was mirrored, it went up like this, right? But now it's gonna go how many units down now? 1, 2, 3, 4, 5, 6. No, it's actually 4 units going to 0, then another 4, negative 4 going downwards. So it's gonna be in total of what? Of 8 units. So it's gonna be there's gonna be reflection. Okay, let's just write it down. This is what happens here. This translation by minus 8 units, right? Which means it's gonna go down. Then there's a reflection um, on the line y is equal to negative 4. Okay, so it was reflected, then it was brought down by 8 units down. All right. Okay, we can go to the next one now. Okay, so question 6. Sorry for that. We're gonna go to question 6. uh, Question 6 is saying the graph of f of x is equal to 4 over x minus 2 and g of x is equal to mx plus c are drawn below. Okay, at point 4 and 4, a is equal to point 4 and 4, x is equal to 4, y is equal to 4, b, then there's also d, which is x is equal to 0 and y is equal to minus 4, and e are points on g. Okay, so on the graph g, which one is this one here? So this one is G, the linear line. B is the x-intercepts of both F and G. Okay, this is F and G. Okay, fine. So the intercepting one, here and here. All right. Both, okay, that is B and E are points on the intersection, B and E. Okay, of F and G. AC is parallel to the y-axis. Y is AC, it's parallel to the y-axis. A, okay, this one is parallel to the y-axis. All right, it's fine. With C, a point on F, where C, okay, this is C here. Okay, it's fine. Okay, now they're saying determine the values of M and C. Okay, where's M? Okay, okay, M is here on the linear line. Okay, so always when you're talking about a linear graph, okay, this is the form, right? Y is equal to mx plus c, where m is equal to what? M is equal to the gradient, and c is equal to what? Um, when this small c is equal to y-intercept, right? Y-intercept. Okay, so that is the form for the linear equation. All right. So now they're saying, can you determine the point, the values of m and c? Okay. So if we look at this line here, this line, we got 2 points. If we have 2 points, we can calculate m. Okay, so we got the point A here on this line G, and this point D here, where it is crossing over the what? The y-axis here. D, where x is equal to 0 and y is equal to minus 4. So we can actually calculate our gradient. So m is equal to the gradient is equal to delta change in y over change in what? In x. Okay. So what is our y values? It's 4 minus, what is the y value here? 4 minus minus 4, right? Over change in x, which is 4 minus 0. Okay. So what is going to be the values here? 4 minus minus 4, that result in a plus. So it's 4 plus 4, which is 8 over 4. So our gradient is positive, which is going to be 2. All right. So our m is 2. And what is our y? Our y is the y-intercept, where it is intercepting the y line, which is here. So what is the y value here? The y value is minus 4. So um, our c, which is equal to the y-intercept, right? Let me just y-intercept. C is equal to y-intercept, which is equal to minus 4, right? So we got our m and our c here. So that g of x, the function of g, it's gonna be what? G of x is equal to what? 2x, right? Minus 4. Okay. Okay, so that's it. 2x minus 4. All right. Now let's go on to the next question. So they say write down the range of f. Okay. So they're saying write down the range of f. So which one is f here? So f is our hyperbola. where the asymptote here is let's see the asymptote. The asymptote is -2. Okay, so this is our hyperbola. It's gonna be like what? That f of x is equal to 4 over x minus 2, where the -2 here is the what? Is the what do you call it? The asymptote here. So it's always like this. You can write it as this: y is equal to, for the hyperbola, where we have our a over x minus let's say maybe c, right? Where this one, the c value, c is equal to what? The asymptote. Asymptote, right? I hope it's the right spelling. All right. So we're gonna come here. They're saying what is the range? So when you're talking about the range, we're talking about the range is the y values. Remember, the range is the y values, the domain is the x values. So the range is our y values. So as we can see from here, what are the y values? So we see on the values of y, yeah, the asymptote is what? Is -2, which means we can have all the y values from negative infinity up until -2. Then it doesn't cross, right? And also here, we see it is coming from positive infinity until it reaches 2, then it never touches -2, until it reaches -2 actually, right? So our range of y values is going to be like, let's just do it like this. The range of y values is going to be like, we're coming from negative infinity up until we try to reach here at -2. So it's what? Minus infinity. It's less than or equal to y is less than -2, because it never touches -2. So we're going to put less than or equal to, just say less than. Okay. And also, it's going to start from here, from positive infinity up until it comes close to -2. Okay. So it's what? It's going to be -2. It's greater than, less than actually, less than y, right? Less than or equal to positive infinity, right? So this is our range of the y values. It never touches the value of -2. So it can take any value except the value of -2, right? Okay. Let's go on to the next one. We're going to determine the coordinates of the points of intersection of the two graphs algebraically. Okay. Okay, so we're going to do it like this. Let me just, okay, let me go on and use this down here. Okay. So point of intersection of the two graphs, we're going to try to equate. So on these points, point of intersection, we see here and here, right? Yes. So we got our g of x. Our g of x is it's fine. G of x. G of x is equal to 4 over x minus 2, right? It's actually f of x. This one, not g of x. Okay. So f of x, right? F of x. Okay. Then we go to our g of x. Let's go to what? What do we get here? Okay, we got 2x minus 4. 2x minus 4. Okay. So we're gonna try to see yeah, so this one is g of x, this one is f of x. Okay, so and the point of intersection, we can see the values of y will be the same, right? The values of y will be the same. Okay, so we're going to try to equate at this point because they've got the same values, right? So they've got the same y values. So we're going to equate here first, like f of x is equal to g of x when they intersect, right? So we're going to equate these two equations here because f of x is equal to g of x at their point of intersection, right? So we're going to f over x minus 2 is equal to 2x minus 4. All right. Now let's try to solve this. We're going to try to multiply here by x, right? So it's going to come to 4 is equal to minus 2x. Yeah, sorry for that. 4 minus 2x. We're going to multiply by x every time. Okay. Let's go to 2x squared minus 4x, right? Okay, so we're going to try to put this side, or you're going to become what? 0 is equal to 2x squared minus 4x plus 2x minus 4, right? So it's going to become 2x squared minus 2x minus 4. Okay, all right. So we're going to look for values. Okay, so this one is 2, it's not 1. So you have to multiply 2 and 4, which is 8. The values we can multiply to get 8, but if we sum them up, they're going to result in 2. You're going to have what? That is 4 and 2. Okay, let's go on here. We're going to write it like this: 2x squared, that is minus 4x plus 2x minus 4. Okay, so here factor out 2x, that is x minus 2x here is going to become 2. And yes, and here we factor out plus 2, it's going to become x minus 2. Okay, so our answer is going to be 2x plus 2, all right? X minus 2 is equal to 0. So now we equate 2x plus 2 equal to 0, and x minus 2 is equal to 0. So now bring this on this side, 2 is equal to 2, minus 2 actually. Then x is equal to 2. Then here we're going to divide it by 2. Divide by 2. So x is equal to minus 1 or 2, right? So these points are going to be what? Because we see now this one, it's going to be what? Minus 1. This is equal to 2. What we're going to do now is check. Now this one is negative, so it's going to go on the negative side of this Cartesian plane, and the positive is going to come. So the positive, which is 2, is going to be here, and the negative 1 is here, right? So we just have to highlight here. This one is the x is equal to 2, x is equal to 2. Then this one is equal to the x is equal to 1, right? Let's put it like this. X is got negative 1 here. Okay. All right. All right. So they want let's check, where are we? The points of intersection. Okay, so here we can actually see now they're crossing on the here on this point here. So it's what? X is equal to 2, y is equal to 0, because it's on this line. It's on the y is equal to 0 here, which is the origin going on the x, which is 2 and 0. So the first point is what? The point, what is the point? It's b. Coordinates of b are b is equal to 2 and 0, right? Okay, we go on to the coordinates of e. Now we can just input in any function f of x or m of mx plus C to get the value of y here at E. Okay, so we're gonna do it like this. What is the value of x here? We got x is equal to -1, right? So let's put it in f of x here. Okay, let me just brush this one up. Okay, so we're gonna come here. We're gonna try to put when y is equal to, no, actually x is equal to 1. That's where it is intersecting, because we found the value of x on this intersection, which is when x is equal to -1. We put it in this equation. So our f of x becomes what? F of x, which is our y value, is equal to 4 over a -1 minus 2. So now -4 minus 2 here, it's going to be what? Our y value is going to be -6. All right. So now if you have a -6, so which means this point E is equal to -1, -6. Okay. And our B is equal to 2 and 0. Okay. So now let's go to the next one. Let me just brush this one out. This one out. Okay, now we go on to the next one, which is 6.4. Okay, let me just clear this one out first. Okay, so we're gonna go to 6.4. What is 6.4 requiring? So 6.4 is saying determine the values of x for which g of x is greater than or equal to f of x. Okay, g of x, g of x when g of x is greater than or equal to f of x. So we're going to be checking the values of y for which this function, this line here, is greater than or equal to the values of y on this hyperbola here. Okay, so where is g of x? G of x is this line. So we are coming from this side and to this side. Let's just check here. So when you're checking here, the values of f of x are above the values of what? G of x in the negative here. So this one are actually much, here it's bigger on f of x. It's actually bigger than g of x, which doesn't satisfy this relationship. Okay, so we're gonna come here after this point here, the values of g of x. Okay, the values of g of x, they are bigger up until here when we cross the y-intercept. So from here to here, you can see the values of f of x here are actually lower than the values of what? Of g of x here, right? So let's try just to let me just try to shade it. Look at this part here. Okay, so from here to here, the values of g of x are actually bigger because you see they're above the values of f of x here. Okay, up until 0 here, you crossed x is equal to 0. Then after this, you can see the values of f of x here are actually bigger than the values of g of x because they are under here. But soon after crossing here, okay, let me just put a line. There, just some dotted line. Okay, soon after crossing the point B here, we can actually see the values of g of x are actually now higher. This one is going down, this one is still going higher. So now this one, the values of what? Y values of g of x are becoming greater than these ones which are going down, which are already also in the negative. These ones are positive. So from here, okay, up until we touch here, right? So all this shaded area here, and then the values satisfy this relationship. So let's check out these values now. So starting from -1, okay. So from -1, -1, right? Starting from -1 here, up until we reach 0. -1 is less than or equal to x less than or equal to 0, right there. And also the values 2, from 2, right? 2 is greater than or equal to x is greater than or equal both up until infinity. This one will be higher than this one. And equal to what? To infinity. Okay, there you go. Okay, just show you a sign of infinity. Nice. It's not like that. It's not this ugly. Okay, there we go. It's gonna be like this. Okay, so these values, these ranges satisfy this inequality here. Okay, so now let's go on to the next one. Okay, so the next one is requiring us to calculate the value of AC. So what is AC? Where is AC? So AC is this value. Okay, so we got this point and this point, right? Okay, this one is parallel to this line, which means the values of x here, since it is parallel, the values of x here and at C is the same, which is 4 and 4, right? Okay, so the values at C, okay, so this is calculating, this is calculating AC, right? So we got AC, but now the values of what? So coordinates of C is equal to, let's write Y, let's just write it as 4, comma, this one is unknown, right? The 4 we know because this one is parallel to this, which means this point here is the same on this line. It's not changing. That's why it's parallel to this one. This one is perpendicular to this one. So here, it's also perpendicular to this line, which means this point and this point on the x is the same. Okay. So now we can put this one in this formula, which is f of x. F of x is equal to 4 over 2, 4 over x actually, minus 2. But now our point here, at this point here, our x is 4. So now we replace x with 4, 4 over 4 minus 2. So what is our y value here? 4 over 4 is 1 minus 2. So our y value is equal to what? Minus 1. Okay, so the coordinates there at C, now it's what? It's equal to 4 and minus 1. Okay, so now we have our points. Now we're going to try to calculate the difference in the because since this one there's no change in the x values, we just find the difference between these 2 points, which is 4 here and minus 1. So our length our length of AC, length of AC is equal to 4 or minus 1, okay, which is equal to 4 plus 1, which is 5, right? Okay, so that one is 5. Okay, so that is our what? Our length. All right, so going on to the next question, which is number 7. The question is saying, given the equation of an exponential graph, that is h of x is equal to a dot b to the x plus q. So we have been given this information of the function for which 0 is less than a is less than 2, and a is a subset of a actually is a number which is an integer, right? Right. A is an element of an integer. Okay, so the range of h is actually y is greater than 2. Y is greater than minus 2 actually. All right. So that means all the y values on this graph are actually greater than minus 2. Okay, and also a, which is a point 1, x is equal to 1, y is equal to 0, is a point on the graph. Okay, so now they are requiring us for 7.1 to write down the equation of the asymptote of h. Okay, let's sketch it. It's gonna be like this. Okay, so normally that is the sketch of an exponential graph which has this form y is equal to let's say a to the x, right? So here the asymptote, our asymptote is the y is equal to 0, right? And the y is equal to 0. Okay, so if we actually add any constant, let's say plus like here in this form here, that's q. So now it's what? Y is equal to 0 plus q. Okay, so y is equal to q. That will be our what? Our equation of the asymptote, right? Okay, so obviously all the time the asymptote will come on this constant which comes after this form, this term here. Okay, so normally if it's just y is equal to a to the x without plus a constant, then the asymptote will be 0, y is equal to 0. All right, so we're gonna go to the next one. Determine the equation of h. Okay, let me just rub this one. Okay. So they said write down the equation of h. Okay. Okay, so if we're gonna use the point here, we've been given a point on h, which is a 1 and 0, like this. Okay. All right, there you go. So we're gonna input it in this h of x equation, which is gonna be like h of x is equal to a dot b. What is our x is equal to 1 plus that is our q. Okay, but here h of x, the value of y is 0. It's going to be 0 is equal to a b plus q. Okay, But as you can see from there, let's try to find the value of Q. We've actually been given like the value of A here, right? It's in between 0 and 2, and also the range of H is Y is greater than -2. So now, because normally on this graph, the range of Y is actually from 0 here going upwards, and now we've been given the range now as -2. So this graph is actually shifted, which is 2 units going in the negative, because we've been given the range of H is equal to Y is equal to -2. Originally, the range of H without this Q here, it's from 0 to infinity there. And now, because it's been translated, because now the range is different, it's not 0, it's -2, so we're gonna shift 2 units down, which is -1, -2. Okay, so let's just write it there. Let's just write it there. We're gonna shift it, which is 2 units down. It's at -1 or -2. So our graph is gonna come like this, and it's gonna cross at 1 now. Not, it's gonna cross at -1, not at 1 here. Okay, because it's gonna shift also this point 2 units down, which is 1, 2 units. Okay, so our graph is gonna be like that. Okay. All right. So our asymptote now is what? -2, not actually the 0. So we know now our Q is what? Q is equal to -2. Q is equal to -2. All right. Now we've been given the conditions for A. We've been given A is 0 is less than A, less than 2, and A is an element of what? Of integer. Okay, but the integer is between what? 0 and 2. Okay, so it's greater than 0, but it's less than 2. So the only integer between these two numbers is what? It's 1. Okay, that's the only integer between 0 and 2. So now we know our A is equal to what? 1. Okay. So now we're gonna go like, we use this equation again. Equation 1. All right. Now we're gonna input A and our Q into this equation, which is equation 1. So it's gonna be done like what? 0 is equal to A is 1 dot B plus, okay, now this one is -2. So it's gonna be what? B 1 times B is just B, -2 is equal to 0. We're making B subject of the formula. We're gonna bring 2 to the other side. It's gonna become B is equal to 2, right? So now our formula becomes h of x, right, is equal to, our A is 1 dot, our B is 2 to the x, right, plus -2, okay, which becomes 1 times 2 to the x is just 2 to the x, -2. Okay, so that is our answer. H of x is equal to 2x minus 2. All right, now let's go on to the next one. It's actually to write down the y-intercept of h. Okay, so what is the y-intercept of h here? Okay, so the y-intercept of h now, because we have shifted the graph, that is like -2 units down, because our q is -2. So that means previously our y-intercept was actually 1. It will cross on the 1 value, that is the y value, all the time, if there's no other constant like this one here, which is a plus q. All right. So originally our intercept was 1, but because we shifted, we translated this graph with this plus minus 2. So it's going to shift 2 units down. So that number is going to be 1 minus 2. So it becomes minus 1. Okay. So our y value, y-intercept of h is equal to, because originally it's 1, so we say 1 minus 2, that is equal to minus 1 value. So the value of y is minus 1, right? Or the coordinates is uh, 0 and minus 1 for the y-intercept. All right, so let's go on to the next question. That is question number 8. Okay, let's talk about number 8. Okay, so we have been given events which are A and B, right? For which the probability of getting A is 0.43, the probability of getting B, that is 0.37, and the probability of getting A and B, that is equal to 0.1591. Okay, so they're asking us here, determine whether events A and B are complementary. Okay, so complementary events, for events to be complementary, we have to prove this identity, which is probability of getting A plus the probability of getting B. If it is true that they are complementary, this should be equal to 1. Okay, so now let's see if our probabilities here can give us 1. Okay, so the probability of getting A, that is 0.43, right? Plus the probability of getting B, that is 0.37, which is equal to what? 0.37, that is equal to what? 0.8, which is not equal to 1, right? So therefore, probability of getting A plus probability of getting B is not equal to 1. Therefore, they are not what? Therefore, they are not complementary. Complementary. All right. Let's go on to question 2. Are events A and B mutually exclusive? Explain your answer. Okay. So let's see if our events are mutually exclusive. All right. So for events to be mutually exclusive, uh, it must satisfy this condition, which is probability of getting A intersection B must be equal to 0, like they shouldn't meet at all, right? All right. So if we draw a Venn diagram, okay, this is just a sketch of A and B. Okay, so this is mutually uh, exclusive events, right? Like this, if they're like this, they are not having any intersection at all. So the probability of getting A intersecting B, it should be equal to 0. Then they are mutually exclusive like this. But we have been given probability of A intersecting B is equal to 0.1591. Therefore, probability of getting A and intersection B is not equal to what? 0. Therefore, they are not mutually not mutually exclusive. All right. Okay, let's go on to the next one. Okay, so we're gonna do the question 8.3. Okay, so that is 8.3, right? So draw a Venn diagram to represent the information above. Okay. So first of all, we have to we know our probability of getting A and B. That is probability of getting A intersection B is 0.15. Yeah, that's written here, right? Okay, now we're gonna calculate the probability of getting A only. Okay, probability of getting A only, that is equal to probability of getting A minus the probability of getting B. That is the probability of getting A intersection B, right? So we're gonna get 0.43 minus 0.159. Okay, so that will give us 0.271. We repeat the same method to get probability of getting B only, right? That is probability of getting B minus that is probability of getting A intersection B, right? Which is equal to 0.37 minus 0.159. Okay, so we're gonna get 0.211. Okay, so that is the probability of getting A only and B only. All right. Okay, so now we're gonna calculate the probability of getting A complementary and B complementary. Okay, neither A nor B. Okay, so can do it like this. It's actually 1 minus probability of getting A, probability of getting B, right? Actually, it's a minus. Let me just make it correct there. Okay, so minus here. I'm gonna say minus probability of getting B, right? Plus the probability of getting A and B. Okay, or we can write it as, and alternatively, we can write it as the probability 1 minus uh, probability of getting A, right, minus probability of getting that is A only here, minus probability of getting B only, right? Minus that is probability of getting A and B, probability of getting A and B. Okay, so all of this will result in the same number, which is equal to 0.359. All right, so now we get what? Now we're going to place all these things in a Venn diagram. Let's just try to draw the Venn diagram. Draw the Venn diagram here. Okay. So now this is the whole sample space. All right. Okay. That is the whole sample space here. And we got our A and our B. And we got our A and our B. Okay, so we got our set A, we got our B here. So our A now is what is 0.271. Our B is 0.2, that is 11. And here in the middle, it's what 0.159. And out here, it's what 0.359. Okay, so that is our Venn diagram. That is how we draw it. All right. Okay, so question number 9 is showing two different events. That is event A and event B. Okay, so this event A and event B, they form part of an investigation. Okay, so the probability of getting A, that is 2/3. The probability of getting B complementary is equal to 3/5. Then the probability of getting A or B is equal to 4/7. So now they're saying determine the value of P not A, which is P A complementary. Okay, so we go to 9.1. Okay, so P not A, which is equal to P A complementary. That is okay, this is how we're going to find it. So probability of getting A plus probability of getting A complementary, this identity should be equal to 1. All right, so now we've been given probability of getting A, which is 2/3, plus probability of getting A complementary is equal to 1. Okay, so making this one subject formula, A complementary is equal to 1 minus 2/3, which is equal to what? A third. All right, so let's go on to the next one, which is 9.2. 9.2. Okay, so probability of getting B. How do we calculate that one? We're going to use the same method because we've been given B complementary here. Okay, so we're going to use the same one, which is probability of getting B. That's probability of getting B complementary is equal to 1. All right, but so probability of getting B plus B complementary, we have been given 3/5 is equal to 1. So making some the formula of this one, B, probability of getting B is equal to 1 minus 3 over 5. So this one is going to give us 2 over 5. Okay, so let's go on to the last one. Okay, so the last one is 9.3, which is saying probability of getting A and B. Okay, so probability of getting A and B is probability A intersection B. So how do you find this one? So so we use this identity, which is probability of getting A plus probability of getting B minus probability of getting A intersection B is equal to that is probability of getting A or B, right? So on this one, we got probability of getting A, probability of getting B, but we don't have this one. Also, we have this one. Okay, so we can equate that is probability of getting A is what? Is 2 over 5 plus the probability of getting B that we found. It's actually 2 over 5. Probability of getting B is actually 2 over 5, right? Minus probability of getting A intersection B, that is equal to probability of getting A or B, that is 4 over 7. Okay, now we do subject formula on this. So it's going to be what? 2 over 5 plus 2 over 5. Okay, so this one may have made a mistake, which is probability of getting A 2 over 3, not 2 over 5. You have to be watchful of these mistakes. Okay, 2 over 3. All right. All right, so like this. Then you say we'll put this one this other side and bring 4 over 7 this side. We'll just 4 over 7 is equal to probability is equal to probability of getting A intersection B. Okay, so 2 over 3 plus 2 over 5 minus 4 over 7. That will result in what? 52. Okay, 52 all over 105. Okay, so that is the probability of getting what? Probability of getting A and B. All right, so basically that's it. We have finished the exam. All right. So thank you guys.